most of us, a trip to Southeast Asia usually means a relaxing holiday in an exotic location.
Unfortunately, some of us bring back a souvenir that can have fatal consequences, not only to ourselves, but to those around us.
Typically, about 10 years ago, we would have on average about 10 imported dengue cases. And now it's up to like 30, 40, 50 a year. Dengue's gotten worse and worse.
In 2009, I reported on an outbreak in Cairns.
In Cairns alone, they're spraying up to 300 houses a day.
One person died and thousands were infected.
It just overcame me all of a sudden. It was like being hit by a truck, and I really did feel as though I was going to die at one stage. The pain was just so much, and there was nothing I could do to abate that feeling of pain.
Unfortunately, there's not much in the way of drugs to treat dengue fever. Sufferers just have to let the infection take its course.
I was drinking lots of water and just lying there. There was really nothing I could do.
The Aedes aegypti mosquito is responsible for spreading the virus between humans. It draws up blood from an infected person and festers in the mozzie for 12 days. When it bites its victim, the mosquito transfers the virus through its saliva to the next victim. 400 years ago, dengue was only found in Africa, but now with global travel, we see it spread all over the world.
I think the most seriously affected country would be Brazil. They report hundreds of thousands of cases every year. Southeast Asia as well, throughout Indonesia, Vietnam, Thailand.
Australia's love affair with barley has meant the number of dengue cases brought back here from Southeast Asia has quadrupled in the last few years.
It's out of control. We have really no good, effective control measures.
Let's have a look.
When I last met Professors Ritchie and O'Neill, they were working on a way of curbing mosquito populations. They discovered that by injecting mosquitoes with a bacterium called Wolbachia, they could stop the dengue virus from replicating in the insect.
So the initial trials that we did when you were last here was to see if it would invade in what they call a semi-filled cage, so a simulated environment.
Wow, this is like a real backyard.
Well, that's exactly what it's supposed to be.
They were successful in a controlled environment, but would it work in a real-life situation?
In 2011, we went to two little suburbs of Cairns, Gordonville and Yorkeys Knob, and we released over about a 12-week period and got successful invasion.
We wanted to get a good understanding of whether we could establish Wolbachia into more urban areas and then see it spread throughout the community.
It meant they had to get busy breeding thousands and thousands of mozzies with Wolbachia to release into the population.
So, Scott, there are about 4,000 mosquitoes in here?
Absolutely. This is our open or free-range mosquito cage. And so the mosquitoes do everything they do in a natural setting in a Cairns backyard. They mate, they fly around. We have human volunteers who sit in here for 10 minutes and let them feed on themselves.
Like I could be now.
Like right now. And then we have buckets where they lay eggs.
Right.
It's all infected with Wolbachia.
Right. So what happens from this stage?
So from this stage, we take them into the other room where there are no free-flying mosquitoes, and we hatch them out and rear the larvae and put them into cups for release in the field.
The mosquitoes start maturing over the next week until they're adults and ready to be released into the population.
Basically, we've got about 8 or 9 houses in the street to do.
The next day, I went out with the team to release the mozzies.
So how long do you expect that it will take to infiltrate the population? Is it only a few weeks?
Previously in experiments, it took about a month or two for it to start going up right up to close to 100%. And we're really hoping that it'll happen the same here.
And the neighbours obviously know that you're releasing mozzies into their backyard?
That's correct. It's all completely voluntary. People can say no, but we get overwhelming support for our project.
And these mosquitoes definitely don't contain dengue.
The mosquitoes we're releasing do not have dengue virus in them. They've got a bacteria called Wolbachia that makes them resistant to dengue.
They were able to gauge their success by setting up electronic traps to collect mosquitoes in the area and send them back to Melbourne for testing.
Well, I'll find out the results a little later on, but first I'm off to Brisbane to meet a team of researchers working on another weapon in the battle against dengue.
Professors Matt Cooper and Paul Young have been working on a way to test for dengue rapidly.
The problem with dengue when it infects patients is that you get undifferentiated fevers that can be diagnosed as pretty much anything. In some endemic countries where malaria is present, you can't actually tell in the early stages a malaria patient from a dengue patient.
These researchers have identified a protein which will tell you if someone has dengue during the early stages of the disease.
First we put some sample into this tube. You put the strip in, wait for the fluid to wick up, and if the sample is positive, it contains NS1 in the solution, you'll get a nice red-coloured stripe.
There are 4 strains of dengue virus, and it's possible for one person to be infected with all 4 strains.
Now, if you initially become infected with dengue, say with type 2, you'll be protected against that subtype for the rest of your life. But if you acquire a second infection with a different subtype, the severity of that disease is much worse.
If you have a secondary infection, that can be really dangerous. It can lead to what's called dengue hemorrhagic fever, which is bleeding, internal bleeding, and that leads to death. So knowing a patient has secondary dengue is very, very important.
These researchers have figured out a blood test that can tell the difference between an initial or subsequent infection.
We've developed a rapid test that can be taken to the field and into small clinics. But in places where dengue is endemic, really quick and simple and easy to use is the key. So this is it. It comes in a little package, which is just keeping it away from humidity and from damage.
So it's portable,
It's portable. There's no moving parts. There's no batteries. And if you look at that,
looks like a pregnancy test.
Yeah, spot on. That's exactly right. In this case, we're going to use blood and test for dengue.
Within minutes, the test is ready to read.
And if we have a look closely, we can see that the M line is lit up. That means that this person has had a recent dengue infection, which is not good. But more importantly, the G line is up. That means this person has got a secondary infection.
So potentially they'd be quite sick.
That's quite dangerous. It means they could go on and get hemorrhagic fever and internal bleeding. So we really want to watch out for that person.
They can even use this technology to enable surveillance of dengue outbreaks and isolate anyone who's infected.
Another issue with dengue outbreaks is that it cripples the supply of blood donors from that area. In the 2009 epidemic, the Blood Service noticed a significant reduction in whole blood stocks from far north Queensland.
Just over 3,000 whole blood donations were affected in Cairns, and so that equated to about 1,500 litres of whole blood that we weren't able to utilise.
At the moment, there's no screening test for blood affected by dengue, so they're forced to reject donations from people who are at risk. That's why the Blood Service is working with Queensland researchers to develop a rapid, on-the-spot test to see whether a potential donor is infected.
The aim of this research project is to develop a test that can detect the actual virus itself, as well as the NS1 antigen, which is part of the virus, as well as antibodies, which is the host's immune response to the virus. The aim is to detect all 3 in the one tube.
We need to be more than 99.9% accurate. For blood screening, there are no second chances, so it has to be as accurate as possible.
I've come to Melbourne to see how the trials in Cairns turned out.
The mozzies get shipped down by courier from Cairns once a week. They come into the lab, put into a machine that measures the amount of Wolbachia in each mosquito and tells us not only whether it's present or not, but how much is there.
That information is collected and mapped across the release area to give a clear picture of how the Wolbachia-infected mosquitoes are spreading.
So we're looking at a map here of Cairns. You can see the residential streets and a series of circles, and each of those circles represents a trap where we've been collecting mosquitoes, and The green piece represents the proportion of mosquitoes at that trap that have Wolbachia. So this is tracking very well for week 4.
So what level of penetration do you expect before you see an impact on dengue rates?
Our goal is to get to 100%, but even if we're below 100%, if we're at around 80%, we should be able to see a significant impact on dengue transmission in that particular area.
By the end of summer, there was around 90% transmission, and even mosquitoes in neighbouring houses outside the release area were infected with Wolbachia. With results like these, the idea of eradicating dengue is getting closer.
I think we could see significant reductions in dengue disease in communities and hopefully in regional areas eliminate transmission. One day the hope is that we might be able to think about eradication of dengue.
There's upwards of 50 to 100 million infections of dengue every year and a huge impact, both societal and economic, in many countries. Any of those approaches, vaccines, antivirals or vector control that can alleviate some of that suffering is obviously good.
We've eradicated smallpox. We're having a go at malaria and TB. We can absolutely eradicate dengue, but we all need to work together.